So a conditional generative model, here the basic idea is if you built a good one of these, you could get both realism and reactivity at once. You could basically get everything that the market replay would give you and more. We're not quite there yet, and that's what I'll tell you about in the next couple of slides. But first, let me just show you the basic idea of a conditional generative model through a specific example. There are others. There are denoising diffusions. There are conditional variational autoencoders and stuff. But let's just talk about GANs today. So here is an unconditional generative adversarial network, just a high-level schematic. The basic idea is, at the end, you're going to produce a generator. That's what you're trying to do. You're trying to produce a generator that, for example, is going to give you faces of people that don't exist. How does it do this and how do they look realistic? It does it via this setup where a discriminator is going to be fed stuff produced by the generator or real samples, meaning real faces of real people, and it is going to give I call it a score. It could be a probability, but it's not always. It depends on the exact losses and so on, of that data being real or fake. Did it come from the training data or did it come from the generator? And when the thing is fully trained, if it was a probability, this discriminator should basically be saying half-half. It can't tell. And what's cool, if you haven't seen this schematic before, is these things work extremely well. But note, in this setup, the generator is never directly seeing the real faces. That happens indirectly via the discriminator giving these scores. And this really is a very cool thing. I mean, the story goes that Ian Goodfellow had this idea and literally went home that night and just coded it up, and he had it working on MNIST immediately, basically. MNIST is handwriting digits. And since then, there have been various issues with getting very high quality faces, for example, or getting enough diversity. So, you know, for example, if you train on people with different skin tones, maybe you only get one skin tone coming out or whatever. There have been various issues, but loads of progress over the last 5-10 years, and these are really impressive now. And probably you've heard of, you know, deep fakes and all of these things. That's intimately related to this stuff. One thing I didn't say is this is taking, you know, what differentiates one run of the generator from another. It's the random noise that you put in. So that you can think of that as maybe a multi-dimensional Gaussian. And that's getting turned into the face. Or potentially a market, you know, a market evolution that we're going to see next. But we actually want a conditional one. And actually the MNIST example is quite good for this. So now during training, you're not only going to have a real digit, you're also going to remember the label of that digit and pass that in. So was this a 1? Was this a 7? Was this a 0? And what's nice about that is then when you actually deploy the generator, you can actually ask it for give me a 7 or give me a 1. And that's crucial for our application because instead of saying give me a 1, give me a 0, we're going to be saying things like give me the next order for the limit order book based on our summary of the recent market action in the limit order book. So that's how you should think of using a conditional generative adversarial network in the context of limit order book simulation. Have some featurized representation of what the limit order book's been doing recently, pass that in as the conditioning, and the goal of the generator is to give you a plausible next order. And, you know, it may be giving you an order that is not fully specified, and then you have some rule for turning it into the actual next order. And that other bit I'm going to call the kind of mechanism of the simulator. So the CGAN is one part, but there are other parts that can also be potentially exploited by an RL agent. Concretely, I'll give you one example of something that we exploited in the work I'll talk about in a sec. There was a CGAN of this sort that we explored where it was producing an order and it was producing it as a depth relative to the best bid and best ask. But then we actually found that because it was doing this relative to the best bid and best ask, we could actually manipulate the best bid and best ask and actually get desirable results for a trading agent that way. So, you know, the CGAN is one part, but there's also the way that the output is interpreted and used to really give a next order in a full limit order book.